Okay, in the last video, we covered topics 1 through 4, which was multiplying. In 5 and 6 down here is what we're going to cover in this video, and it's factoring quadratics. Okay, so first I just want to take a look at those diamond problems that you've been working on in CP/M for the last 3 years. They help us think about factoring and what we're going to be doing. So there really was a reason why we gave you those problems. They weren't just random puzzles. So remember that if you take 7 times a -5, that goes here, right? And 7 plus a -5 goes here. Okay. This diamond idea is really going to help us with the factoring problems that we're going to do, because you're going to know these two purple numbers. You're trying to find the red numbers when you're factoring. Okay, so we're just going to keep that in mind. So we're being asked to factor this trinomial. What does factor mean? Factor means to break something down into its factors. Factors are things that you multiply one another by. So for instance, the number 40, we could break it down into lots of different factors, but I could break it down to, for instance, 2 and 20, or I could break it down to 4 and 10, right? Or 8 and 5. Okay, those are all the factor pairs for 40. So if I'm being asked to factor this trinomial, we're looking for two binomials that when you multiply them together result in x squared plus 5x plus 6. So to do that, you really need to have a good sense of FOIL, using FOIL. So I know that when I multiply this by this, I'm going to get x squared, right? The firsts result in x squared. So it's got to be x and x. X times x is x squared. And then I have the outers and the inners, and those have to add up to 5. And the lasts, you have to multiply them and you get 6. Okay, so here's where the diamond problems come in handy. If I draw my diamond, I know that multiply and add. Okay, I know that these two numbers, when I multiply them, equal 6. So I'll put 6 here. And when I add them, they're going to add up to a positive 5. Two numbers, when you multiply, result in 6, add is 5. Well, that's pretty easy. That's going to result in a 3 and a 2. Okay, so what does that mean? That means that we have 3 and 2, positive 3 and positive 2. So x plus 3 times x plus 2 is the factored form of that trinomial, right? You could check x times x is x squared first. The outers, the inners, the lasts. If I combined these, added them together, I end up with 5x. Okay. All right, let's take a look at the next one. Okay. When I multiply, right, we know first of all that we have x and x, right? X times x is x squared. We know that when we multiply the two numbers, we're going to end up with a -15. When we add the numbers, we're going to end up with a positive 2. Okay, what two numbers when you multiply result in 15? Well, 3 and 5. I need it to add to a positive 2, so it must be a positive 5 and a -3, right? Multiply, add, positive 2. So I have x plus 5, x minus 3. Okay, factored form. All right, let's take a look at a couple more. Write these down. You can pause. Right? Go ahead and write your diamonds. We have multiply and add on bottom, multiply and add. So when I multiply the numbers, the result is a -28. When I add them, it's a -3. So let's see, what two numbers multiply to result in 28? I'm really good at these. I've been doing them a really long time. I've got 7 and 4. So which one has to be bigger? If I add these, I need a -3. The negative number has to be bigger. So I've got x minus 7, x plus 4. Let's take a look at this one. When I multiply the two numbers, I get 12. When I add the two numbers, I get a -7. Okay, how about 3 and 4? They both have to be negative if I'm going to result in a positive 12. When I multiply and when I add, I get a negative 7. X minus 3, x minus 4. Okay, 2 examples left. Or excuse me, no, we've got 4. What the heck do we do with this one? X squared minus 16. Well, we could take a look at our normal method. When I multiply the two numbers, I get a negative 16. When I add the numbers, there's no middle term. So that means 0, right? This is the same as x squared plus 0x minus 16. Oh, well, that means it must be 4 and negative 4. So I've got an x minus 4, x plus 4. So I'm going to pause here and not use this type of method here for this next problem. This is what's called the difference of squares. Perfect square, perfect square. So if you have a number squared minus a number squared, difference meaning subtraction, right? Difference meaning subtraction of two squares, then it can be factored into the square root of this and the square root of that. Square root, square root. One's positive, one's negative. So what does that mean? Well, this was x squared and that was 4 squared. So my result was x minus 4, x plus 4. So let's take a look at this one. We have x squared minus 100. This is 10 squared, right? This is x squared minus 10 squared. So if I'm going to factor this, it's going to be x plus 10, x minus 10. Difference of squares. Just take the square root of the two numbers. It only works for the difference of squares. There is no way to factor the sum of squares. That is not factorable. Difference only. Difference of squares only. Okay. Uh-oh. We have a situation here where this is not just x squared. It's got a coefficient in front of it. Well, what we could first do before we start factoring is look and see if we can factor what we call the greatest common factor out of each term. What can be factored out of each term? Well, each one of these is divisible by 2. So I'm going to divide each of these by 2 and pull that out. So if I divide this by 2, this just becomes x squared. Divide this by 2, plus 9x. Divide this by 2, I get 14. Okay. Do you see how I did that? I just divided out the 2. Now I can factor this like I had been, right? When I multiply them, I get 14. When I add them, I get 9. So it must be 7 and 2. So I have 2, x plus 7, x plus 2. That is fully factored. All right, let's take a look at this one down here. All right, what can be factored out of each? Well, I think they're all divisible by 4. We'll take the 4 out. I have x squared plus 3x. Negative 72 divided by 4 is negative 18. Now we're going to have to find the two terms there. I have negative 18 and a positive 3. How about a 6 and a negative 3? So I have 4, x plus 6, x minus 3.